Hello, everyone. Welcome. Thank you for joining us today. We are glad to have you. Before we get started, I'll do some quick introductions, take you over to Acelab for just a moment, and then we'll get started with the presentation. My name's Kayla. I'm here from representing the Acelab team. We also have Jeff here from Brava. Let me take over screen share just a minute and show you Brava's page in Acelab. So in just a moment, you should be able to see my screen. Here we are in Acelab. If you're not familiar already, a great way to do some general research in Acelab is using the search bar at the top of the page. In this case, you just want to make sure you toggle over to manufacturers to find Brava's page. And here we are. We have some really great information here for you. We've got Jeff's contact information right here, front and center as well. So feel free to jump into their page, explore these products. If you can click into each one of these pages to learn more, you can also click right here to save any of these products to your firm library for future reference. So yeah, I'll send this link in the chat for you all so you can check out their page and learn a little bit more about what they do. And a couple other things to make note of for today. This is an AIA-approved presentation, and we collected all of your AIA numbers upon registration. So you're most likely already good to go there. If you're worried we didn't get your number, I will also put a form in the chat so you can fill that out and make sure that we get your correct number. We also will be doing Q&A at the very end. So if you have any questions throughout the presentation, don't hesitate to drop those in the Q&A box at the bottom of your screen. You can just click that and drop the questions there, and we'll get to as many as we can at the end. We will also have a webinar poll that will pop up for during the presentation. That actually is optional. So again, no need to really worry about it. If you're not interested in getting any kind of follow-up after the webinar today, you can just click the X. And then if you are interested in getting follow-up, any kind of specific information, product literature, samples, things like that, fill out the form. Feel free to specify a specific project that you may have in mind. We will get you connected via an Acelab conversation. So you'll see a notification for that conversation come through in your inbox. So you can respond directly to that email, or you can log into your Acelab account and respond there. It's a great way to get some additional questions answered from Jeff and his team. So definitely keep an eye out for that if you do fill out the poll. And last but not least, we also will be doing a post-webinar survey. So we definitely appreciate any feedback that you have on this presentation and just the webinar process in general. So feel free to leave anything like that there in the post-webinar survey. And that's everything from my end. So Jeff, I'll pass it to you to get us started.
All right. Thank you so much, Kayla. Thank you, Acelab, for hosting. My name is Jeff. As Kayla mentioned, I'm with Brava Roof Tile. I'm the A&D Business Development Director. We manufacture synthetic sustainable roofing materials. We, essentially recycle plastic into sustainable roofing. So this CEU is what makes a product sustainable, and what does that mean for roofing? Mostly, this is just going to be, we're going to discuss sustainable manufacturing, sustainable products. So first off, the AIA statement. As Kayla mentioned, I will be submitting all of your information. So the course description, obviously sustainability and sustainable products are everywhere today. There's a lot of information. Many manufacturers like to make claims about how their product or technology is sustainable. What we're trying to do is really just provide a good understanding, good background, good information about how we can really investigate, validate, and confirm or compare all of the information that we receive to make sure that we are specifying products that are meeting our goals for sustainable development. So we'll take a look at a lot of different topics, but going through our learning objectives, we're going to look at some of the timeline of events that shaped the field of sustainability. So how did we get to where we are today? We'll look at some materials, including renewable resources, the recycled content, embodied carbon, look at and understand production and manufacturing processes, review ethical sourcing and supply chain concerns, review product and material cycle design, life cycle design and assessments, and then finally look at some real world examples, mostly in roofing, but these are all going to be applicable to sustainable design practice. So often viewed as a modern concept, sustainability really does trace back its roots to the early 19th century and mid 20th century. So conservation efforts were led by surprisingly authors, philosophers, your Henry David Thoreau, John Muir, that we're all pretty familiar with, our conservationist president, Teddy Roosevelt, and author Rachel Carson with her book Silent Spring in the early 60s. The modern sustainability movement really gained momentum post World War II. So we see this huge rush of industrialization with the rebuilding of Europe, the baby boom in the US, population growth all around the globe. We started to raise concerns about what this is going to do to not only human beings, but also to our environment. So how is rapid industrialization, pollution, and population growth going to impact how we live? To address this, the UN decided in 1972 at the Stockholm Conference to form their environment program. So that gets launched in 1972 in Stockholm to address these issues. Also at that time, a separate group of leading environmentalists and scientists were formed as the Group of Rome, and they launched their limits to growth. So this was a study warning about or investigating unchecked economic and population growth and how we could possibly exceed the Earth's carrying capacity within the century if left unchecked. If you aren't familiar with the limits to growth or the World 3 model, I suggest it's a fun toy or tool to play around with to see. It's pretty enlightening to see how population growth and resource scarcity impacts the world. So Google World 3 and you can check that out. But environmental concerns really continued to intensify after 1972. So you have large-scale crises like the 1973 and 1979 oil shortages. You start to see a pattern of global equity or global inequity between northern and southern hemispheres. So you have your developing nations in the northern hemisphere, which are taking a lot of resources, and it's not always equitable between the northern and southern hemisphere. That is a growing concern. So the UN realizes this, and in 1983 forms or creates the Brundtland Commission to address these challenges. So they appointed Gro Harlem Brundtland as the chairman or chairperson of this commission. Gro Harlem Brundtland was a three-term prime minister from Norway, and the commission's goal was to investigate and provide guidance on how to address growing global concerns over environmental challenges and explore the relationship between environmental issues and socioeconomic development. In 1987, the Brundtland Commission publishes Our Common Future, which is a really landmark study. So the commission releases the Brundtland report, and among other things, the real pivotal role in along with playing a pivotal role in shaping the sustainability movement, they introduced the definition that we still use today of sustainability, meeting the needs of the present without compromising the ability of future generations to meet their own. So really a shared intergenerational responsibility. Along with these different other concepts, key sustainability concepts that were founded in the Brundtland Commission report, again, emphasizing integration of economic growth, environmental protection, and social equality. So if anybody's familiar with John Elkington, the triple bottom line, really just balancing our needs for development with our needs for environmentalism and our needs for social equity. As I mentioned, intergenerational responsibilities. So thinking about the needs of future generations, promoting integrated system-based thinking. So working with policymakers to really encourage breaking down the silos and viewing development holistically, understanding all the factors that are incorporated here. Elevated global cooperation. So we know that what we do in North America influences what happens in Europe and vice versa. Our countries aren't operating in vacuums. What we put into the air affects people on the opposite side of the globe. And then paving the way for future global frameworks. So influencing the creation of Millennium Development Goals, our focused on poverty reduction and sustainable development goals, you know, really focusing on a comprehensive and integrative approach to sustainable development and equality. The UN Environment Program also introduced us to created the UN Sustainable Consumption and Product Guidelines in 1994 at their Oslo meeting. So they started the definition, or the base definition, of a sustainable product is one that provides environmental, social, and economic benefits while protecting public health and the environment over its full life cycle, from the extraction of raw materials to the final disposal. So really important basis for sustainability. And with this in mind, we'll start with materials and then progress from there. So raw materials, we're all familiar with a lot of these terms, but a raw material is a basic, unrefined resource. It's extracted from nature and then transformed into a finished product through industrial or manufacturing process. We're probably familiar with renewable resources, recycled content, term biodegradable, but let's review and just make sure our understanding of the definitions align. And then we'll look at some key metrics and tools, and then a little bit about embodied carbon. So renewable resources, in the name, it's right there. They can replenish naturally over time, and they regenerate at a rate faster than their consumption. So, and their extraction has a very low or minimal impact on the environment. So we know that materials will regenerate, even iron ore, crude oil, coal, natural gas, but we consider those non-renewable because their regeneration rate is much slower than their consumption rate. So we are depleting. Examples of regenerative or renewable materials: bamboo, poplar, pine, agricultural byproducts, wool, timber, cotton, hemp, and then your renewable energies, wind, solar, hydro. There are a lot of good certifications out there to make sure you are choosing a renewable source. In the timber industry, which I'm showing up top, you have your FSC, you have the SFI, or the Sustainable Forestry Initiative, or forest stewardship. Lots of different options, but you want to make sure you're looking for a certified renewable resource backed by third-party certifications, whether it's chain of custody or forest management certifications. It's a good idea to make sure you're looking at those. Recycled content is another common term that we hear a lot. You have your virgin materials, which are extracted from the earth. We're using them the first time. Then you have your recycled content. So post-industrial is just materials reclaimed from manufacturing waste. So say you're running a bottle plant for a soda manufacturer, you run 500,000 bottles, they're out of spec. You used to just grind up that material and it would just go to a landfill. Now, because we do have the ability to grind and repurpose this material, you can turn it into something like synthetic roofing. Post-consumer content, similarly, is materials recovered from used products. So I drink a soda bottle, I throw it in the recycling, goes to a recycling plant, they take it and separate, process it, and then send it out to manufacturers. And this is a little bit more difficult to get a steady stream for manufacturers, but a wonderful use. Again, this is a product that can be used in something like a synthetic roof tile, recycled glass tiles, or insulation. Understanding the rules, why this matters for sustainability. So when we're looking at sustainability as a whole, recycled content helps us by not using virgin materials and using the same material over and over, reduce, reuse, recycle. But when we recycle, we are flattening the carbon footprint. So looking at the embodied carbon in a material, when we recycle, we're able to flatten that carbon and disseminate it over multiple years and really expand its impact. We hear about biodegradable frequently. So biodegradable is essentially just any substance that can break down naturally. So we're going to look at anything that'll break down into non-toxic components, water, carbon dioxide, within a reasonable time frame. So there are 4 real characteristics of biodegradable materials. First being it breaks down naturally, so decomposes into natural elements without our intervention. So um, just bacteria, fungi, microorganisms naturally occurring will break down this material, so it's biodegradable. Also, it will leave a non-toxic residue, so we're not looking at leaving microplastics or other harmful chemicals when these products break down. That wouldn't be biodegradable. Time frame for decomposition, months or a few years. Everything's going to degrade or decompose, but we want to make sure that, unlike plastics that take a few centuries, hundreds of years, we're looking at materials that are breaking down naturally over the course of a few months to a few years. So some of the key metrics and tools, some of the biggest tools that we have, life cycle assessment models. So probably the most important tool in life cycle assessments to evaluate the environmental impact of material of a product across its useful life. So from extraction to production to disposal, it gives us a really detailed picture of the energy and water use. It gives us a detailed picture of the emissions and the pollution associated with this material, and also the resource depletion. Life cycle assessments will follow your ISO standards, so we know that we're comparing apples to apples. Also helpful tools, EPDs, so your third-party verified documents that summarize a lot of life cycle assessment results. Most of these are going to be cradle to gate, so this is going to be the upfront embodied carbon that it shows you. But because these EPDs are standardized, it really gives us a format to make good comparisons. So apples to apples versus your apples to oranges comparisons. Embodied carbon, so probably the most commonly referenced metric in sustainability. So the total amount of greenhouse gas that's associated with the producing of the material. That's going to include your extraction, processing, transportation. It's also going to include your maintenance and service. And then it's after its useful life, it's decommissioning or again back into its recycling or deconstruction. Material health assessments, so your HPDs, so understanding how this material, the chemical concerns, is it safe, is it toxic, what's its impact on the building occupants, and what's its impact more greater on the environment. Other things to consider, your sourcing transparency, ethical certifications, recycled content that we mentioned earlier, and your water and energy intensity. So looking at embodied carbon, again, just kind of to beat a dead horse. So it's going to focus on the emissions created through the raw material extraction process. So whether it's mining or logging, material processing or manufacturing, transportation, construction and installation, and then your maintenance, repair, and eventual demolition. So understanding and making sure we know these are happening is very important. These two just slides or visuals here just to give you an understanding of the life cycle assessment, the different phases. So you have your product and construction phase, use and maintenance phase, and then end of life phase. So where is the carbon coming from? Mostly it's going to be involved in that cradle to gate, but construction phase and then the use and maintenance. Not included in there is your operational carbon or your operational phase, which you see to the right. So your operational is, exactly that. It's not embodied, it's operational. So some of the manufacturing processes that play a big or impact sustainability significantly. So good manufacturers are looking at options to decrease their decrease their carbon footprint. Lean manufacturing has been around for a long time. It's a wonderful philosophy. So the goal is just to eliminate waste from waste, or as they refer to it, muda in Japanese, without sacrificing productivity. So you want to focus on your efficiency, your continuous improvement or the Kaizen, and maximizing the value for customers. So the environmental benefits associated with this, you're going to reduce your overall production, your energy use, your defects. My apologies. Defects and excess inventory. So you really want to encourage efficient use of material and time. Closed loop manufacturing, this is going to be designing systems where materials are reused, remanufactured, or recycled back into the production cycle. So if a manufacturer is machining, using plastic, they're taking the offal and either recycling it back into their material, minimizing the need for virgin raw materials so we can use recycled content. Circular manufacturing. So, an example of this would be using recycled polymer to manufacture, either synthetic roofing tiles or other synthetic materials. Zero waste. So the goal here is to design and manage products and process to systematically eliminate waste. So the guiding principle here is waste is a design flaw, not an inevitability. So we can continue to refine and improve our process where we are not creating waste. Our environmental benefits, we're reducing landfill use, we are improving our efficiency, we're reducing pollution and raw material extraction. Zero to landfill is very similar to zero waste, but this really is just ensuring that no manufacturing or operational waste ends up in landfills. So it focuses strictly on landfill avoidance, even if some waste is incinerated for energy or something similar. Benefits, we're just reducing environmental degradation from landfilling. So looking at some some energy efficiency opportunities. So retrofitting facilities for energy efficiency is going to play a huge role. You can add solar to the top of your building. You can change who you're purchasing from. Just having, adaptive energy in your buildings is very important. Can you add a motion light sensor to the break room so we're not using electricity while nobody's in there? These all add up over time that go into your carbon footprint that should be considered. Digital tools for tracking internally. How do we optimize energy use? Do we understand the flow of our manufacturing floor? These are all ways to increase our energy efficiency, and we can do this with not only energy, but water and other goods. So some examples of leadership in manufacturing, just a few outside of the building industry. Subaru of Indiana, they're the first auto assembly plant to achieve zero to landfill. They've been doing this for over 20 years, since 2004. They recycle or use 100% of their manufacturing waste. So even their cafeteria is composting all of the waste, and some of the remaining biomass or trash is converted to energy. So this is important. I think one of the challenges that we get caught up in is, we focus solely on the manufacturing operations where you have all these ancillary operations, your cafeteria, your break room, just your offices, and you don't. Some offices aren't recycling or not recycling properly. We have a lot of waste in these areas, and good, truly aligned, sustainable manufacturers will consider everything from operations to supply chain to manufacturing to ensure 100% sustainability focus. Companies like Patagonia, so really strong commitment to zero waste. They became a B Corp. They are a zero waste manufacturer, really believe in circularity. So not only a circularity of their manufacturing, but they've got the repair and reuse program. So they've been able to turn their waste reduction into a design principle and a brand value, upcycling materials and production, minimal packaging and lean logistics. And then Procter and Gamble, so another massive manufacturer, over 85% of their production facilities now send zero manufacturing waste to landfills. So their philosophy is let's turn our waste, let's treat our waste as a resource and integrate it into circularity in our global operations rather than focusing it as a byproduct. Looking at some developments in supply chains. So this is where a lot of our emissions come from, distribution and logistics. So accounting for our emissions, there are three types or three different emission scopes. You'll hear them referred to as scope 1, scope 2, and scope 3. 2 and 3 are indirect emissions. Scope 1 is direct emissions. So emissions from sources that the entity either owns or controls. So this includes anything from boilers, furnaces, vehicles, any of your manufacturing equipment, all of this that goes into stuff that I, as a manufacturer, can control is considered a direct emission scope, that scope 1. Scope 2, indirect emissions from energy. So I can go to my local energy provider and say, hey, I want to use renewables. This is in nearly every company's ability to do, but emissions generated from purchased electricity, steam, heating, and cooling. Scope 2, and then scope 3 is other indirect emissions. This is the largest scope and also the most difficult to quantify. So this includes everything upstream and downstream in the value chain. So supply chain, business travel, product use, waste, transportation not owned by the company. So even a retailer, their their scope 3 indirect emissions would include me, Joe homeowner, driving from my home to their warehouse to pick up my material and then coming back. So really a large scope. Transportation modes. So a lot of the information that we have in EPDs are going to be typically cradle to gate. So once that leaves the factory, we don't really have a direct line of sight on the impacts associated with their transportation. So understanding, one, what different transportations, how they impact your products, but two, you can reach out to manufacturers like myself and inquire about how we are shipping our material. This is a large impact or a large factor into our emissions or our carbon footprint. We want to be just cognizant of this. So the lower emissions, obviously it's efficiency at scale. Rail is great, but rail has its challenges. So long distances are fantastic. You can ship a lot, but you're always going to be doing a last mile or using some form of delivery vehicle to get your material from your rail yard to site. Semi trucks, great, very convenient, but again, heavy emissions, improving, but they all have their challenges with emissions. Ocean freight, the most efficient, but a huge, also a large polluter. So the port emissions and delays, especially with some of the challenges that we see, if you have a pandemic or some other global event, can really challenge or make you inefficient. This is when we start looking at, should we spend a little bit more money and purchase domestically versus imported? What is the carbon footprint of a long distance shipping? If we're getting a great deal on our material or our raw material, the least expensive, how do we weigh the pros and cons against that when the carbon footprint is much more significant shipping in from, South America or Asia? That's when we need to really do a study, balance our localized production with our access to innovative imported materials. So is it worth it to bring material in? Can we apply that technology locally? These are all considerations that manufacturers are making. And then nearshoring. So does it make sense for us to nearshore something, bring our material in, manufacture in a third country, and then send it here? The challenges that all manufacturers are going to deal with. Optimization techniques. So one of the probably most famous optimization techniques with smart logistics and planning, UPS trucks, for the longest time, they don't turn left. So this is a studied and verified thing. They don't almost never turn left because you can't turn left on red. So many logistics operators will optimize their routes. So, time spent waiting to turn left, you're creating emissions, you're burning fuel. If you can turn right, it's going to be much faster. You're going to decrease your emissions. Localizing your supply chain, again, does it make sense for us to purchase from across the world when we can purchase here for slightly more? It improves our supply chain, it improves our relationships with our local manufacturer, it improves the local economy. So there's features and benefits that you really need to evaluate. And then evaluating your suppliers based on their transportation emissions. So, are they being as efficient as possible? Ethical sourcing. So it doesn't stop just at, bringing the material in, how we pull it out of the earth. We need to make sure that we're verifying the source of our raw materials to ensure they are sustainable and ethically sourced. So one of the biggest challenges that we have to do that is how do we, get eyes of sight on that? And with both of these concerns, supply chain transparency, it's going to involve a lot of auditing. Auditing is not cheap, but it's responsible, and we want to make sure that we are doing everything we can to make sure that we are operating ethically and sustainably. Fair trade, so making sure that we are not taking advantage of developing nations. With a much stronger dollar or much stronger currency going to a developing nation, we want to make sure that we're paying a fair dollar or fair amount for their materials. Even though they would probably accept less, we don't want to create more inequalities or exacerbate inequalities that are existing. There are plenty of great certifiers, Fairtrade, BREEAM, all have really great third-party certifications. Safety and ethical labor practices, again, working with choosing manufacturers that are not only working to eliminate this, but auditing and making sure that their current suppliers are not participating and their third-party suppliers are being audited properly. A proper audit will be an independent third-party auditor. One of the challenges that we see frequently is I will, as a manufacturer, you go to a supplier of raw materials, you can audit that supplier. They're perfect, but they may be sourcing a lot of their raw materials from another company or another provider who is not ethical. So we want to make sure that we are doing our due diligence and investigating, auditing to make sure that we are not, even if we're kind of purposely being blind. So just make sure you're working with companies that audit suppliers for compliance. One of the strangest things, ESG has been kind of corrupted, or the understanding of ESG. It really makes a lot of sense to invest heavily in ESG, environmental social governance, having those uh, policies enacted. We are going to audit 90% of our raw material providers annually. Those are good policies that protect a company long term. Yes, they're expensive, but protecting your company long term and your reputation from getting surprised, finding out that a warehouse are you using somewhere is employing child labor. It's very avoidable if you do have those policies in place. Emerging technologies. So blockchain is becoming a big player. The fishing industry uses a lot of blockchain, or seafood industry uses a lot of blockchain. This helps us make sure that we can trace this and confidently trace and make sure that there's no funny business or shenanigans down the line where we're getting material that we from a different source. We're not getting material from a Siberian tiger's habitat that was deforested. Making sure that we can trace confidently all the way back to the place of origin. We also have new AI tools that can detect irregularities in sourcing procedures. So just a lot of new technology that's going to help us get smarter in the future. So life cycles, we really want to make sure that when you're performing life cycle assessments to understand, the full footprint of your product. So there's two kind of overarching ones, your cradle to grave and cradle to cradle. So we want to move away from cradle to grave, the linear model where we go from extraction to production to disposal. Really not a ton of benefits, probably a little bit less expensive, but really going to grow a lot of landfill waste, greenhouse gas emissions, and we're depleting our resources without resupplying. Cradle to cradle, the way of the future, the circular model, designing products for disassembly, reuse, and recycling. So we want to reap the benefits for the building industry, some modular components, recyclable roofing systems, really being able to take an existing good, recycle it, and turning it back into something useful is the way of the future, and it's the way we flatten the curve, or make sure that we are reducing our embodied carbon and our carbon footprint. End of life disposal. So making sure that your manufacturer has strategies in place to ensure that materials can either be dismantled and repurposed or recycled. Examples of this are take-back programs. So your carpet tiles, metal roofing, products that we can work with the manufacturer to get it back to the factory, and then recycle or reuse. Life cycle assessment tools, again, very helpful for us here. Evaluating LCAs is one of the best ways to inform your material selection. Again, we have our ISO standards to help us ensure that we're looking at things apples to apples comparison. There are plenty of life cycle analysis softwares out there for assessing the environmental impact. And then your life cycle inventory databases. So these are repositories. The Department of Energy had a very robust one, has a very robust one. Hopefully it will stay intact and it'll continue to be supported. But these are going to give us an idea about the total energy resource impacts of developing and commercial building materials, components, assemblies, so we can make good decisions. So greenwashing is a big challenge. So like we saw, we continue to see in food advertising, a lot of these terms are, kind of being preyed on by marketers. So we know that we want to purchase green materials. Marketing people, business people know that, sustainable materials sell. So I'm going to make my products sound like it's sustainable. So the definition of greenwashing: practice of conveying a false impression or providing misleading information about how a product is environmentally sound. So we're taking people's demand, what they want to do, exploiting their interests, and selling them materials without the environmental benefits. So this really sets everybody back. So it distorts our marketing, changes people's conception of what an actual sustainable product is. It misleads you, our design professionals, and it delays our progress, ultimately working against us towards carbon neutrality. So just some examples to look out for. So your vague claims, eco-friendly, natural, this is a green product. Well, what does that mean? We don't really know. Hidden trade-offs. So it's there's no VOC or no this is a really great product, super recyclable, but high VOCs. No proof, backed by third-party data. Anybody can make a claim. They'll probably face lawsuits eventually, but you need to make sure that claims are certified. Irrelevant claims, false labels. So in the building industry, I don't know how many green labels there are, over 500, I'm sure. So just making sure that you're working with a good, reputable green label. And then lesser two evils comparing, hey, this is greener than a really catastrophic product. So making sure that you're paying attention there. Recycling, just some real world examples. I won't beat you over the head with this, but fast fashion, you could probably Google and figure out which one this was, but really making green label claims. And once we looked into it, or once somebody investigated it, all of them fall apart, 96%. Fake green labels, again, big challenge. And then, a trash bag manufacturer saying, hey, this is designated to handle all types of recyclables, but the bag is not recyclable itself. How to spot. So that's how to spot and avoid greenwashing. Again, look for your certifications. Use verified tools and databases. So we all know Mindful Materials, HPDs, Declare, Red List, Pharaoh's Project. All of these are resources that we have at our fingertips that we can always use to verify. Checking the EPDs, so making sure that a company has EPDs, they're third-party verified. You can be confident in the information there. Overuse of green imagery or language. Just because something has a plant on the bottle doesn't mean that it is green. And then request transparency. So as a manufacturer, as somebody who's been in the building industry on the opposite side from you for the longest time, I will never get offended or upset if somebody asks me to back up my claims. It's part of the business. It is what any responsible manufacturer will do. They will provide information. The more transparent we can be, the better you can be. It's a win-win situation. So hold people's feet to the fire, demand transparency. Concepts of greenwashing or consequences, again, market confusion. It really sets us back. So people, will bash or do something unethical and really impact all of the industry. We want to make sure that we are presenting everything a truthful, a certified, realistic light. So some of the material concerns, obviously we look at the sustainable part of a product, but how they perform really matters. So energy efficiency, probably the most important. A good sustainable product will minimize energy during operation. Even if it's something like installing a motion detector into a light switch, we are minimizing our energy use to only during operable periods. So whether it's being more efficient or just cutting, becoming adaptive, big important part of sustainable products. Harvesting or regenerating energy. So solar is a huge opportunity here. Wind, your regenerative braking systems, solar integrated panels, regenerative elevators. I worked with a company that made regenerative door openers. So every time I opened up a door, the closer was regenerating energy. So you could, eventually open up the door with a power assist and not pull any energy off the grid. Longer lifespan and durability, again, flattening that curve of the embodied carbon. So the longer a product lasts, the more efficient it is, or the less waste we encounter, the lower the embodied carbon. Great example of this: synthetic roofing versus asphalt shingles. Asphalt shingles, you can get a 25-year shingle, um, probably going to last you 12 to 15 years with a more resilient synthetic material, or a metal. You're going to get a close to a 50-year material or a 50-year lifetime. So the decreased maintenance and the decreased replacement going to be much more environmentally friendly and sustainable. Low maintenance requirements. So, again, low maintenance, not having to get in there and, do cost prohibitive, energy intensive maintenance to upkeep your products, helps reduce your carbon footprint. Modular and upgradable design. So this is something that really is going to be the future of sustainability. So making sure that we don't need a phone. I know there are technophiles out there who, I want a new phone every year, but it's so incredibly wasteful. Phones, computers, appliances. We really want things that are going to last for a long time, and products that are upgradable modularly. So I am desperately waiting for a phone manufacturer or a computer manufacturer to create something that, just give me a chip that improves the performance of my phone. I don't need a thinner screen. I don't need a thinner profile. I don't need smudge-proof this and a marginally better camera every other year. I just want something that works. I want something that'll improve, cut down on the manufacturing, cut down on the waste, and let's do modular upgrades. Smart systems and adaptive performance. So, thermostats are huge here. Changing lighting along with your daylighting. Adaptive systems are going to be key to increasing our efficiency. And then water efficiency. So your low flow plumbing fixtures, gray water reuse, really excellent for conservation. I think one of the best examples of this is drip irrigation. So not really building related, but if you look at the massive improvement in eliminating or making us more efficient with water use, drip irrigation rather than standard irrigation. We're running tubing, which is probably a little bit more expensive, but we're providing it to the crops. You can make sure that all of your water all of your irrigation is going directly to the plants. You can put through your fertilizers. So not only are we decreasing our water use, we're also decreasing our chemical use. So I try and think of water efficiency, drip irrigation, or if you're in a manufacturing facility, reusing, recollecting, purifying water, and then sending it back in a closed loop system. Again, a great example of water efficiency. So getting into roofing. So how does this translate to roofing? So some of the really awesome products that have come out or gained wide scale acceptance. Metal roofs are not a new thing. We've had corrugated metal roofs forever, but some standing seam materials, they're made from recycled products, like aluminum and steel. Aluminum, a wonderful workhorse of sustainability. Their lifespan exceeds 50 years. They're recyclable at the end of the use, and they reflect heat. So they will increase your performance of your building. They're low maintenance, long-term cost savings because they are great material. Some cool roofing materials. So cool roofing, if you're not familiar with it, if you're not doing a lot of work in California, Title 24, just evaluating materials for their reflectivity and their emissivity, hoping to mitigate urban heat islands, reduce HVAC loads, and these are largely achieved with coatings or just different colored materials. They're designed to reflect more sunlight and absorb less heat. So adoption in both commercial and residentials, this makes a meaningful difference in hot climates, or even high altitude. They will help you long term. green living roofs. So what's better than having a green roof? Natural insulation, stormwater management, and improves our air quality. Can't say anything better about it. Um, we're seeing trends. This is mandated in some cities, looking at Toronto's green roof bylaw, but really just an awesome. It's expensive, I know, but really just a wonderful advancement. Solar integration, so helps us reduce our reliance on the grid. Um, blends the newer integrated roofing systems really look solid. You're kind of doing away with the old giant solar panels. Those are still here and they're not going anywhere, but integrated systems really are starting to look awesome. This is largely due to the advancement in not only the technologies, but our ability to transmit. So adoption regions with renewable energy incentives, hopefully those stay. Unfortunately, we're losing a lot of those incentives as we go. And then synthetic roofing, great products made from recycled materials, including plastics and rubber. So we're keeping material out of the landfill. They're highly durable. They're resilient. They have extended lives. They're lightweight, made from recycled material, and then fully recyclable at the end of their life. Just great solutions. So some of the future for sustainable materials, um, bio-based insulation, carbon negative concrete, solar integrated roofing systems. These are things that, probably were once thought of as, that's impossible to design or create, but we've made so many advancements in these areas that they're really going to start becoming the the way that we manufacture smart materials. So I wouldn't say I'm a Luddite, but I feel like I don't need technology and everything, but some materials that are coming out, will have monitoring or are smart so they can be adaptive. So there are going to be some really great smart materials that come out that will change with environmental conditions. Policies and regulations, we want to be advocates for increasing our focus on embodied carbon limits in building codes. That's going to be, again, the way we flatten this curve. And then incentives for using sustainable materials on public projects. Uh, Not only is sustainable, better for the earth, but it's a better spend. So sustainable has over the years gotten I guess a bad reputation, or sustainable has kind of been a buzzword or associated with, oh, this is just environmentally conscious, but it's not a great product. Nowadays, that's flipped. So sustainable should really be efficient. You are looking at a more efficient product. So the long-term life cycle costs, your performance should be more energy efficient. All in all, this is going to be a better, more sustainable product, and sustainable applies to the economics, the equality, and environmentalism of your product. So your role in this, so advocating for sustainable practices, making sure that this is in your design, making sure that you are demanding of your manufacturers that they are manufacturing efficient, sustainable materials, educating your clients. This is why we want to use sustainable materials. This is why it's important. These are the features and benefits that you get from using sustainable materials. Continuing to innovate. So as an industry, including manufacturers and the whole building industry, making sure that we don't stop at any point. We want to continue to innovate and make sure that we're doing what's best for our health, the environment's health, and the equality across the board. And then valuing life cycle costs. I left that for last because that's one of the biggest challenges that I see people dealing with. Hey, we really have a difficult time selling life cycle costs. But if I can make this make sense for you, and the payback happens over time, and the life of your building benefits from it, it's really, it makes sense. It's going to drive us forward. So again, just looking at some of the some of the sustainable products, what to look out for. some of the innovations that have recently come about, and then, really our role in embracing this. All right, so that concludes the CEU portion, and I will burn through this because I know I took up a lot of time. So Brava, again, my name is Jeff. I'm with Brava Roof Tile. So we manufacture synthetic roofing materials. We make cedar shake, slate, Spanish barrel tile. We manufacture in Iowa. We are opening a second plant outside of Atlanta. So we are a US manufacturer. Everything we do is going to be up to about 85% recycled material content. We use mostly post-industrial material, but we do use a significant amount of post-consumer. The challenge that we have is, as a nation, we aren't great at recycling, so having dependable supply of post-consumer recycled content is not always that easy, but we do, up to about 85% recycled content in our products. This is just kind of fluff, but we've been around since 2008. What makes Brava different than other manufacturers in the synthetic roofing category, we are one of the only compression molded manufacturers. We do this because it allows us to increase our detail, and then it allows us to create color variegation. So we sandcast. True examples of the material are cedar shakes, slate, Spanish barrel tiles. We take those molds, then we use our recycled content, raw materials. We combine it with inorganic pigments or mineral pigments. We mix it, and then we compress it at an extremely high PSI. That allows us to get this graining that you see here. It allows us to get that super detailed texture. But the variegation is probably the biggest. So because we essentially we extrude, put everything into a hopper, add our mineral pigments, and loosely put it all together, it extrudes like a Tootsie Roll, comes out, and then we compress it. And when you compress it, you get this variegation, which really just creates a beautiful product. Because we use mineral pigments, we end up with a very fade resistant product with zero maintenance. Our wind resistance, so if you're familiar with roofing or Miami-Dade acceptance, the highest standard, Brava's materials can tolerate up to 150 miles an hour in our warranty. We've been tested to over 211 miles an hour, and in that instance, the product failed, but the deck actually ripped off in the testing machine, so it was more of a catastrophic deck failure than, you got bigger things to worry about if you have 200-mile winds. Fade resistance, again, our mineral pigments, we've been tested. So Class A fire assembly, Class 4 hail impact or impact resistance, and that's only because there's nothing higher. This is a 50-year warranty, whether it's commercial or residential. Brava is going to be much thicker than many of the other manufacturers, and then lightweight. So if you have a home that, a homeowner or a building that wants to install slate but isn't engineered for it, you're really out of options. Your only option is to engineer. Well, now you can take a synthetic material that looks like slate, performs like slate, but is as light as, traditional plastic. So the three different shakes or materials. So these are the color options. We tend to go with the color life cycle of cedar. So you get a little bit of red. Your new cedar eventually gets gray, your weathered visual, but really just some beautiful colors. Cool roof colors. So this is going to be for Title 24. So here's some examples of some public projects. Multifamily uses our material. So it's an upgrade, but really makes sense once you start looking at, hey, this is going to last for 50 years and I can get a 50-year warranty. Slate, done some really nice projects here. historical. So this is a house from 1914. This portico is the original slate, and now it's the, Brava. Kayla, am I out of time?
Oh, technically, yes.
All right.
Yeah, maybe we can go ahead and wrap it up
Yeah. All right.
to be respectful of everybody's time.
All right. I'll
Awesome.
stop my share. There's my.
Cool. Well, yeah, thank you, Jeff. There are a few questions, but we can just have you follow up with folks via email afterwards. We'll give you a log of all the questions. And yeah, do you want to wrap us up with any final notes or
Yeah,
comments?
so I would encourage you, please, reach out with any of your questions. Brava is perfect, either residential or commercial, institutional, wonderful opportunity. You can feel good about it. Please, I look forward to hearing your thoughts.
Yeah, absolutely. Thank you so much. It was a really great presentation. I think a lot of people really enjoyed it. So we'll get you connected with those folks afterwards via email. And thank you, Jeff. Thank you, everyone who joined us. We hope you all enjoy the rest of your day.
Thank you.
Thank you.